Every single second, lightning bolts hit the Earth about 100 times, releasing more energy in a flash than some small towns use in an entire day. And that raw, unstoppable power comes from the same force that charges your phone, powers your home, and keeps the entire US economy moving. Electricity isn't just a utility, it's the backbone of modern life, and its story is way wilder than most people ever hear. Electricity is one of those things Americans use constantly but rarely think about. Flip a switch, tap a screen, plug in a device, everything just works. But the science, history, and real-world impact behind it are packed with facts that challenge what we think we know. From the grid that spans millions of miles to the microscopic particles racing inside a copper wire, electricity remains one of the most fascinating forces in nature and technology. Let's start with the US power grid, which is legitimately one of the largest machines ever built. It's not one single system but three interconnected grids: the Eastern Interconnection, the Western Interconnection, and Texas's ERCOT grid. Together, they move electricity across more than 160,000 miles of high-voltage transmission lines. The wild part, even with all that infrastructure, most electricity never travels more than a few hundred miles because energy loss increases over distance. Inside your home, the outlets typically deliver 120 volts, a standard that goes back more than a century. While many countries use 220 to 240 volts, the US stuck with its early standard because it was safer for households when electrical devices were new and far less insulated. That legacy voltage still shapes American appliances today. One of the most surprising truths about electricity is that electrons themselves move slowly, sometimes only centimeters per hour. What moves fast is the electrical signal, traveling near the speed of light. It's similar to pushing one marble into a long line of marbles. The effect travels instantly even though each marble barely moves. Speaking of speed, the US uses an enormous amount of electrical power every day, over 4 trillion kilowatt-hours per year. Air conditioning alone accounts for nearly 12% of residential energy use, which makes sense given how central AC is to American living. Meanwhile, data centers powering the cloud, those servers behind streaming, AI, and social media, consume roughly the same electricity as 5 million US homes. Electricity also isn't something we can easily store at massive scale. Battery tech is improving fast, but the grid still depends heavily on real-time balancing. The exact amount of electricity being used must match the electricity being produced at every moment. If demand spikes, like during a heatwave, the grid operators must instantly ramp up generation or risk outages. It's a 24/7 balancing act handled through forecasting, reserve power plants, and rapid response tech. Renewables are transforming that equation. Wind now produces more electricity in the US than any other renewable source, and some turbines stand taller than the Statue of Liberty. Solar is scaling just as fast. Enough panels are installed nationwide to power more than 30 million American homes when conditions are ideal. Yet one of the coolest facts is that solar panels still generate electricity even on cloudy days, they just run at lower efficiency. Electricity is also deeply tied to American history. In the late 1800s, the famous War of Currents between Thomas Edison, who backed DC power, and Nikola Tesla, who championed AC, shaped the grid we use today. AC won because it could be transmitted long distances more easily, but DC is making a comeback through modern high-voltage DC lines used for long-range, low-loss transmission. Even static electricity, yes, the little shock from your sweater, has serious power behind it. A typical static zap can carry up to 25,000 volts, though at extremely low current, which is why it doesn't seriously injure us. Compare that to a US power outlet at 120 volts, and suddenly that tiny spark becomes a lot more impressive. And here's a fact that blows people's minds: electricity isn't consumed in the traditional sense. What we use is the energy carried by electrons, not the electrons themselves. Those electrons stay inside the wire, moving energy from the power source to your devices and back out again. As America leans into electric cars, AI data centers, smart homes, and renewable energy, the role of electricity will only get bigger. The future grid will need to be smarter, faster, more resilient, and capable of handling massive loads that didn't exist a decade ago. But the core science, charged particles, magnetic fields, and energy conversion, remains the same as it was in Tesla's time. If you found these insights eye-opening, tap that subscribe button and unlock more deep dive breakdowns that make science, tech, and the modern world way easier to understand. Drop a comment on which electricity fact surprised you the most, and stay tuned, because the next video is going to push your curiosity even further.